Dang, there's no fish half the class is left.
You know, they don't play like all the
Yes.
On the movie takes to Eddie Murphy. Eddie Murphy was
don't get a cramp
he was getting over those
brothers.
Her mom making all of the food. What's that?
Who were the jack one day, bro? You're a celebrity. Let me see.
All right, we're gonna go ahead and start. Will, Chase, Audrey, Jacob, Arlo's not here yet. Jacob, Mark, and Terry, you guys are late. You need to be on time tomorrow, or well, don't worry. I guess it's tomorrow.
Yes, sir.
All right, guys, put your phones away. Put them in your pocket. All right, so I think we had almost finished with our model here. Whenever you see a new model, you always need to label the parts, depending on the type of model. If it's an image like this, then yeah. You also need to label the parts and show the direction of any movement or flow. So you should add arrows to the movement of light and also to the movement of the oxygen in the image. Okay.
What about the plant? It's growing upward.
Yeah, not necessarily. And the movement of the plant growth is so small, it's not going to be important at this point. All right, so student number one. Okay, you guys are going to answer number one. Student number two, answer letter A, student number one. Student number two, answer letter B. No. Student number three, answer number C or letter C. And then all of you are, yeah, that's right. Student number four, if you have one, will answer number two or student number one again. Okay, so A, B, and C, but the leader of the group needs to make sure to read them out loud because the whole group needs to be thinking about it. Okay, so the other group repeats the question out loud.
I
can't even
I'll read it, bro.
It should take us long to start reading the question. Let's go.
She didn't even look personal.
I asked her for an answer in the question. She said no. But then Romero answered her, she said yes.
Hey, it's a little distracting, man.
What's it called?
I'm just to the right process.
What process is occurring?
The lights on.
Yeah, because you can't. No, you get a bottle of water, right? Yeah.
Okay.
All right.
We keep going.
Number 2, yeah.
Oh, 6, right. 6. Depending on the environment, the people that is more or less gases may be produced. I mean, they start getting like this.
Yeah. So, yeah.
Sorry, I'll take number 2.
Arlo.
Reduce.
I love.
You get a drink? But hey, what do you want? Yeah, you got time tomorrow.
I'd take number 2.
I can try to Arlo. He takes 30 years.
I really do.
What did you say?
All right. We need another minute.
Looks like we're on the series.
Check his answers. All right, now as a group, go ahead and answer number 3. You're done with the others. As a group together, answer number 3.
If you turn up the lamp,
To measure that? What would be easier? I can know what you're watching.
What they can say?
Oh, that's what the diagram allows you to
Add
do.
them up. Yeah, I said, add them up. Y'all didn't listen. Still in.
March the 3rd.
My son, bro.
Mr. Taylor, I'm sorry, I just had to go on to give me a break.
Yeah,
Hell yeah.
so you probably won't get the chance in the future.
Because I went to the vending machine and they were out, so I went to the next one and they was my $1. So then I had to go out and sell it for $1. And then I just walked back to class.
So, you know, figure that out. You're so fake, like, really, like, really fake.
so like, no, so we're number 3.
Yeah, that would be one thing to change. That's number 2 as well.
That tells me that.
Okay. Need your kids up here. You've got 10 seconds to finish up your conversation.
Oh,
All right, very good. So let's talk about what we got for our answers here to see if we're all on the same page. Let's see who's got a volunteer to answer letter A. Is what's the process occurring in the plants or in the water?
We said photosynthesis.
Good. All right, who's next? What gas is the plant producing? Who's next? Okay.
I put carbon dioxide.
Really? Okay. So, don't plants produce something we need to breathe? Oxygen. Yep, that's all right. Plants actually do produce.
I think it off a little bit.
Plants actually do produce carbon dioxide and oxygen, but mostly carbon dioxide. So she's not wrong. Just a little bit off, and that's okay.
2 hours.
All right. Good, or letter C. What do you got for letter C? Light. Good. Number 2, how are you gonna determine how much oxygen there is?
Come there. Number 2. There would be more bubbles.
That's right, count the bubbles. Okay, and what are the variables that are gonna be, or can be adjusted in this example for number 3? What are the variables that we can work on and change?
The amount of light plane gets and warmth of the water.
Okay, yeah, so maybe temperature and amount of light.
What about the size of the beaker? That could.
Okay, size of the beaker, yeah, we could change that.
Or the amount of water too.
That's true. All right, so move to the next page. We're gonna look at model 2 now. All right, model 2. All right, need the ball back, please. Thank you. All right, hey guys, we're way behind, and I'm going to give each of you individual sheets here if we don't get done in time because we're way behind. There's too much yapping going on. It's too hard for me to keep this moving if you can't be quiet for a minute. So here you see a setup of 4. So the first thing you need to do is label this. So we're going to have top left be A, top right is B, here is C, and then this is D. Now, after you've got that label A, B, C, D, I want you to go ahead and label all the components that you see in letter D. Okay? So label all the components you see here with your okay? Label all the components you see. Now remember, the rule was only use touch. Label the parts.
I'll
The amount of bubbles, like the made is greater and then it's just it down. It increases.
You right? Checking his words. Okay, that's fine. You need to work together.
You're gonna make that quarter down.
By Friday is fine.
I've been ready.
That works.
What if you don't do it?
All right, looks like most of you are done.
What? What if you don't know how to do it?
All right, so stop. Student number 2 is going to do number 4. Student number 3 is going to do number 5. And if you have a student number 4, they'll do 6. But if you don't, student number 1 does number 6. Okay, Mark, say go. Read them out loud. The leader should be reading them out loud to make sure everybody does their part. Student number 2.
First of all, everything is the same.
There shouldn't be any discussion. It should be reading the question and answering it, not deciding still.
How is the condition described in question 5 of the effects of regular gas production by the aquatic plane? Provide specific evidence for model 2 of the and hold me to speak loud.
Okay, I'm doing number 6.
I got a water bid. I got a water
All right, let's go through this, see if we're on the same page. All right, when you labeled it, there's five main things you need labeled: oxygen gas, plant, beaker. Still waiting. You have a screen that's going to block the amount of light that comes in. If you look at the screens in the different trials, you'll see it's a different shade, indicating different amount of light coming through. And of course, the light. When you identify several conditions in the experiment that are the same in each trial, what did you see that were similar in each trial? Jason. Hold on. Jay should be the only one talking.
What stayed the same was the plant in the thing, the water, the beaker, and the lamp. The only thing that changed was the screen, how dark it was.
Okay, good. All right, what about number 5? Describe one condition that has been varied among the 4 trials.
They started placing
Hold on.
a screen in,
Hold on.
they started placing a screen in front of the lamp, and like it got darker like every trial.
Okay, good. And then number 6.
Can you say that one too?
Yeah, go ahead.
I put
Hold on, guys, hold on.
I put the darker the screen, the less gas is produced.
Okay, what's your evidence for that?
Well, because once they started, well, when they
Hold
didn't
on,
have,
hold on, hold on. Guys, it wasn't just Jacob. There's others too.
we're talking about a mistake. All right, so on model A, there was no screen, and a lot of gas got produced. And then B, there was less gas, and as they started darkening the screen, less gas started to appear in the water.
Good. Yeah, so you notice there was a big difference between the beginning and the end, depending on the screen shading and whatnot. Very good. All right. All right, let's go to page 3 now. All right, on page 3, we need to know talk to your group for 30 seconds. What are the patterns you see on model 3? What are the patterns you see on model 3?
I teach flow.
All right, so as a group, go ahead and start filling out the data on the model, on the third model. Fill out the data on that table. Start filling in the information. Where do you guys think you're gonna get the information for on Model 3?
The next, Model 2.
Very good, Model 2. Model 2 will give you your information.
Mr. Taylor? Give me some help already.
Maybe we just count the.
Yeah, I don't see any leaves on there, like, how many, I don't see a certain number of clips.
Okay. Well, it says a clipping, how many leaves on the clipping?
Yes, the length of the.
Okay, it's, the way it copied, the leaves are not visible really, but each clipping has 8 leaves. Okay? A, B, C, and D each have 8 leaves. You can't see them. I didn't realize that at first, so they all have 8 leaves. Okay, so continue on through the chart and go ahead and answer 4 and 5. No, sorry. 8, answer 8, A, B, C. Yeah, I'll be able to share that point behind it later. We're gonna run out of time today. All right, go ahead and staple your papers together, put them on the counter over there. We made it as far as the class, so we'll stop.
It's all in there. Hey, you want to put, what's that, Justin, you want to put the name on it? Yeah. Give him my boy on, give him a free thing. Here's a copy of Mr. Taylor.
You really don't. You don't have to understand. Just, you know.
Where's the, stapler?
It's over by the,
Where's it saved?
It's over there by where you turn it in.
I don't understand. That's water? Yeah. Take her up. Hey. What? Okay. Okay. No. I think you're stable more there. You are.
Why are you saying?
What? Because I saw this side, I was like, here, they were.
Wait, did we switch routes on confused? Don't mix it in there.
Is it, these are new spots?
No, yeah, you sit in your own, sit in your own
Old
spot.
ones?
Yeah, I'll let you know when to move.
Our old spot.
You're all assigned seats.
Mr. Tanner, thought we really switched up.
So, just for special projects.
Oh.
Please don't put me at a comfortable table. I don't like uncomfortable tables. This is pretty uncomfortable. Here's the gym. Trash.
Are you done with the, good work? Look here. Okay. Where's Ryder at? What we doing? Yeah, they're gonna snitch on him, what's up? All right, I need you guys to get in your groups from yesterday. I am gonna make a small adjustment, but get in your groups, take your composition notebook with you. We'll be using the front. Go ahead and move to the front of the book. Thank you. I'm gonna eat it anyway. I'm gonna eat it anyway.
Still in a wrapper.
Wow. I'll just chill for a second. I'll just, all right, so I'm going to group, I'm gonna steal one, because we have a group of 4, and then we've got 2 people who weren't here yesterday. So I'm gonna reconfigure.
So you got a visitor?
All right, good. Now we're gonna have Jake and Levi and Rudy if you guys would scoot over, we're gonna have you guys on this table as well, so we sit you there. You guys would be your group, okay? Eli. Okay, so. All right, so what we're gonna do today is we're gonna get started on the steps and information that we need to gather in order to help us progress in our understanding of what happened to the soap in the microwave. Tomorrow we're gonna be doing a lab with popcorn, but today we gotta get a little bit more information in our heads to get us to that point. So we're gonna be doing a it's a pogil, and some of you have done pogils before. So in the front of your composition notebook, I need you to turn to the second page. You probably already have something there. Just put a line under whatever is there. So you put your line and then put pogil. It's P-O-G-I-L. I don't like my P, so I'm going to do my P here. And then under that, put experimental variables. Variables.
Experimental.
Oh yeah. I do that. I did. I got one of those trailer park document cameras, webcam. That's working. Well, yeah, you know, you kind of Jimmy rig everything in the trailer park, make sure it survives, right? It's actually a really good camera, it's just not its intended purpose, and it's okay to repurpose it. Yep.
What's the sound?
Who's that?
What's in the sound?
Oh, that's a piece of iron that is welded to the, not welded, it's bolted to the rafter pieces, and it's used to demonstrate gravity and some other stuff in physics. You can take a bowling ball from it and swing it, and you can watch it slowly come to a stop. It's cool because if you pull it back and put it at your nose and then let go, it'll swing and it won't hit you again. Unless you lean back. Because if you lean back and then let go, you lean forward, it does pop. We can demonstrate it at some point. The bowling ball I have, I can't actually attach directly to the rope. I've got to drill a hole in the top of it and attach a screw and whatnot, so I can do that. Otherwise, I have to put it in a bucket and attach that to it. It looks kind of another trailer park move, but you know, what are you gonna do? Okay, anyway. Oh yeah, I should probably pass out the paper, you know. Okay. So you're going to be sharing this paper with your group. So anyone from groups, you need to get in a position where you can see. And while I'm passing this out, you guys need to designate. Y'all need to designate a leader and a coordinator. You're all contributors, but you need a leader and a coordinator. The leader is going to read the questions out loud to the group. The coordinator is going to make sure everybody's contributing on their assigned question. I get it. Got it. Hold on, we're not ready yet. I'm glad you're excited. You guys are much better than you guys. I got a little more copy of that. All right, make sure that this is the page you got up. Okay, to give you a little background information, we're going to be developing some scientific language today. And to help you in that quest of developing scientific language that you need to learn to use in class, I've got your composition notebooks open. And if you look, there's some bold words on this paper that are going to be important coming up. The first one is variable. All right. Okay, so the first word that's important, this is the assignment. That's where I've got it there, but the first one is variable. So that's part of the scientific language you're going to develop, and then the next one is controlled experiment. Got two L's?
Yes.
Okay, now looking through the page, can anybody guess what other words might be important that are bold? Yeah, photosynthesis, very good. And any others? Huh? No, it's just on the front page, first page for now. Any other words on the first page that might be important for our scientific language abilities? Yeah, aquatic plant. So I do my Q's like a backwards G. So from now on, that's a backwards G. It's actually a Q, it's a cursive Q, kind of cursive. A little bit cursive. So now you know what my Q's look like. Okay. So let's go through this first paragraph together as we work to try and redevelop our scientific design or conducting experiment skills. Okay. So the question is why? When scientists set out to do an experiment, they first think about the variables that may affect the outcome of the experiment. A variable is any condition that may cause change in the system being studied. That's not a good definition. Some variables are measured quantitatively, like temperature, mass, or height. Other variables are recorded in qualitative manner, like color, texture, or species. The most important factor is that scientists run a controlled experiment. In a controlled experiment, only one variable is changed to ensure that the effect of only that one variable can be measured. Okay, so you have some basic definitions in there for these first two terms that are very beneficial. All right, so what I want you to do next is I want you to, as a group, try to define a model. What is a model? And we have an example of a model right here. So as a group, come up with a working definition for model. You got 1 minute. Go. Yep, you can. So,
They don't want you to.
okay, but all you. This is an experiment. I'm running my own experiment. We'll see. No, see if people can put it down and work with it. There's no such thing as multitask. Mark it. Yeah, that's not multitasking. Multitasking is not real. The ability to switch back and forth between different tasks.
I've heard that.
So your brain can't do two things at once, but it can switch back and forth. Now, there's some things that don't require you to like chewing gum. Chew gum and walk at the same time. But you're also breathing your heart rate, so it's not voluntary. In terms of a habit or a muscle function. But your brain cannot focus on it. Like you can keep rolling a snake while you're talking, because it does require muscle. It's not really multitasking. Okay, sorry, that took longer because I got distracted by a good question or a good discussion. Who can give me a decent definition of a model? What's a model? Sorry, now, who's got the ball?
A model is a depiction of the experiment at hand.
Okay, that'll work. What else? Anybody else?
It's a visual demonstration of what you're doing.
Okay, that can be true.
Model is a representation you use to explain how something works.
Okay, good. Last one.
Representation of what a scenario looks like.
Okay, representation of a scenario, good. So you guys have the basic understanding, a model is some sort of representation of a phenomenon or an observable event. Okay, so a model is a representation of a phenomenon or observable event. Sometimes it's visual, sometimes it's through audio, sometimes it's tactile, you can touch it and feel it. But a model is a physical, or excuse me, a representation of something that's happened. Okay, so here we have a model, and as a group, I want you to go through, well, let's say this. So it's a model of photosynthesis in an aquatic plant. So by hearing those words, you know what you should be investigating or should be looking at. It's dealing with photosynthesis, and you can think, okay, I know what happens in that. At least that's the basics of it. And it's an aquatic plant, so obviously aquatic plant means what?
It lives in water.
Yeah, it's a plant that lives in water or on water, something to that effect. All right, so what I need you to do, anytime you see a new model, especially when it's something like this, you need to label the components. Okay, so as a team, look at the model and label the components. Write it on there. What are the parts of the model? She wasn't the one wearing it. Yeah, you did. Yeah, right on there. Anybody know where I can find some zigzags in a hair? Zigzags in a hair. Oh, look at that right there. You got it going on. In our hair?
It's not the
We're supposed to be labeling. Can you tell me what that is?
Actually,
No, it's not. Why? I'm just saying.
All right, we got them all. All right, hook us up. Start us out with one item we can label in this little thing here. Okay, good. So we got the plant. The plant is the squiggly, and I realized this really late in the game, but there should be some leaves on this plant that you cannot see. So imagine there's little tiny leaves there. There should be leaves on there, but there's not. All right, go ahead and pass it on.
What is the cup dash container?
Okay. You all right if we call it a beaker?
Yeah.
All right, so we've got a beaker here. What else? That's on.
The light.
Good, with the light. Actually, let's call this a lamp. It does produce light, and the normal thing is just to call it a light, but we're gonna use light for something else. Okay, who else? Well, that's cool. My phone's wigging out. It's got the time and date displayed twice. All right.
Oh, so lines coming out of the label light.
Okay, yeah, so we got light coming out of the lamp, so that's what we'll label light. Okay, yes?
The water.
The water, very good. We got water in here. Water up in this mode. Anything else that should be labeled? There might be some heat. Okay. Now, we're lucky because oxygen's already labeled for us, so that makes it easy. Now, one thing we need to do is that anytime you see a model, if there's something moving in the model, you need to show the direction it's moving. Okay? So, what's moving in this model? The light?
The water.
The water, or the light's definitely moving.
The oxygen.
Yeah, the oxygen bubbles are probably gonna move up, right? All right, now you don't have to put arrows on every bubble, but you should have it on at least a few. Very good. All right. Good. So, let's see. I need one person from the group to raise your hand. All right, you are student number 1. No, not both of them, just one. All right, now I need another person to raise your hand. You're student number 2, and the last person is student number 3. And then if you only have 2 people, you can alternate between being student number 1 and 2 and 3. All right, so student number 1 is going to work to answer letter A, student number 2, letter B, student number 3, letter C. However, the leader of the group is going to read the question, and the student I called just now is going to be the one that tries to answer it. Okay, so you're going to do it as a group, kind of, but the leader needs to read it. Student 1, 2, or 3 needs to work to answer it. All right, when you're done with A, B, and C as a group, go ahead and answer 2 and 3 as well. One, 2, and 3.
Listen, depending on the environment.
Put something on the.
Right. Depending on the environment, the plants are more or less gas. Suggested method for measuring the daily gas production from the water plant.
Well, that's not.
Suggested method for measuring. How do you measure it? Wait, I see it right here. How do I know what's there? Thermals. Because it tells you. Because it tells you. What does it tell us? It tells us that this is the option. Yeah. There's 8 on with your group, creating a environmental average that makes fish these capsules become variables.
All right, 30 more seconds.
Don't be anxious. Take over. With your group, create a list of environmental challenges that may affect the commercial gas.
All right, who's got the ball?
I don't have any.
Oh, we got the ball.
I thought you said
All right.
he has them all.
All right. So let's answer these together. Go ahead and answer us. Call me letter A.
You said photosynthesis, what is the process?
Okay, good. Yeah, I like how he said, he didn't just say photosynthesis, he said photosynthesis is the process, the experiment. Very good. All right, pass it for letter B. What gas does the plant produce? Oh,
Oil.
Oxygen's right. All right, letter C, what is the source of energy?
The heat lamp or the lamp.
Okay, and what's coming off the lamp?
Light.
Yeah, light. Good. All right, and how do we know how much gas is there? Hey guys, who's got the ball? How do we know how much gas is there? Who's ready to answer that?
Because the diagram, well, it shows us that there's gas.
Right, but how do we know how much? Yeah, just count the bubbles, right? So how many did we get? 8? Yeah, so always be specific in your answers. So count the bubbles, and if it asks you how much is there, then give specific answers. Very good. All right, and then last, number 3, what are some of the variables that might affect the outcome? You got them all.
We put temperature, the amount of water, type of plant, amount of light, and the distance from the lamp to the water and the meter size.
Very good. Yeah, so there's several there. Okay, so go to page 2 now. Uh-oh. Here's not messed up. You have a number 2.
Yes.
Somehow, this set got messed up when I printed it. That's not mine. All right, model 2. Now, how many experiments are in this picture? 4. Technically, it's still 1. Okay,
One,
but there's 4 versions of it. Okay, so we're going to label those versions. We got A, B, C, and D. All right, so make sure you got that labeled on yours. A, B, C, and D.
Sorry.
All right.
Scared me.
Now, you got A, B, C, and D labeled, right? So A, B, C, D. Now what I want you to do as a group, label all the components that you see in letter D. Don't worry about the rest, just put your labels all for letter D right there. Have all the components.
Just like the.
Okay, those who are not writing, check their work. While we're doing this, I want you to, you can't see them because the copy didn't work very well, but on the stem, in each of these, I want you to draw 8 little leaves. Okay, draw 8 little leaves on those stems. Try not to overlap them with the bubbles. Kylie, it doesn't seem like you're contributing over here. All right. Your argument is sound. Your evidence is strong.
It's trying to lose that. That's trying to. It's how much they want to
Isn't each one?
What?
Can each speaker have a leaf on the front?
Yeah, each speaker needs 8 leaves on it. On the stem, yeah. All right, so what are the things, there should be about 5 things labeled in letter D. What should they be?
translucent slab.
Got the beaker. We'll call this a screen. You got the oxygen, plant, and light. Let's see. Yeah, you could put a lot more, but those are the essential ones that you need to have for sure. Okay. And then if you're doing the right thing, you're going to show the movement that's going to happen within there. Okay, very good. All right. So student 1 does number 4, student 2 does number 5, and student 3 does number 6. But of course, the leader's still reading them, and the other contributors still need to get their input, okay? All right, so do 4, 5, and 6.
Thank you, but no.
Yeah, there's the option with.
All right, we're gonna do another minute. All right. All right. Need your attention back up here. Okay. So what are the conditions in the experiment that are the same in each trial? Got them all right? Go ahead.
The light, water amount, plant size.
Good. Anybody have anything to add to that? Pretty basic, right? Okay, very good. All right, next, describe one condition that has varied among the 4 trials.
Like the degree that the screen constructs the light from reaching the planet.
Okay, good. So they're determined, or they're varying the amount of light that gets through. Very good. And then number 6, how does the condition described in question 5 appear to affect the rate of gas production by the aquatic plants? Provide specific evidence in model 2 to support your answer.
The darker the screen, the less oxygen is produced.
Okay. What's your evidence for that?
Because you can see in the model, as the screen gets darker, there's less oxygen bubbles.
Can you give me a specific example?
Like, now in one, there's 6, 8, and then in the last one, there's 2.
Very good. Very good. All right, let's turn to page 3. Also the third model. Now, as a group, go ahead, go through that for a second and identify what are the patterns you see on this model so far.
What's the number of leaves of clipping?
All right. So I think it's probably pretty straightforward. You can see that the clipping link's the same, the lamp power's the same. The only thing that changes really is the amount of light being allowed through, right? Okay, so as a group, go ahead and answer number 8, A, B, and C. Now, coordinator person, make sure each person is contributing their ideas, okay?
What variable was first? Did you get this right here?
Now, I did forget to tell you, but hopefully you're able to figure this out. You need to fill out the rest of the chart first before you answer the questions, right?
Oh, okay. So.
Fill out the chart first before you answer the questions. It won't work.
What's the number of leaves on this?
What I say.
I remember you told us.
So, they don't understand.
Yes.
What is that? Oh my God.
I did not say that.
All right. Hey, watch it there. All right, up here. So, whoa, come on, Mr. Camera. Didn't like you left it. So how many clippings, how many leaves are on each clipping? 8. Okay, should have drawn 8. I'm trying to print some new ones that look a little better. And then what was the difference you guys noticed in the oxygen output?
It went down by 2.
And went down by 2, right? So you started with 8, 6, 4, 2. Very good.
25% of the light gone to oxygen levels.
Yeah. So there was a pretty significant change there. So what variable did we change? Amount of light. And the results.
I don't think it would be the amount of light, actually. It's like it's like the same amount of light still going there, but it's not reaching it. So like it would just.
Available to.
Right, so the amount of light we're allowing through. Can we see it that way?
Yeah, sure.
Okay. That's a good point. And then, let's see. Yeah. Yeah, so we didn't change anything in A, and then or C, what variable in the Model 3 does will remain constant in all three trials? Well, there were several things, okay? So the clipping stayed the same, the number of leaves stayed the same, the power, and that was it. All right, good deal. We are going to, we're going to do the last part of this tomorrow, or the next time we're here, and then we're going to start the popcorn lab. So make sure everybody's names are on these and stapled together. The staples over there. Oh, by the door. Yeah, so she says, you know, sometimes paper thing with the numbers I call it, talking about it. All that, you guys do this. We make it work for it.
We go homeroom,
I just figured it'd be.
homeroom, call clubs, and then enrichment.
Yeah, I think it
And
is.
then second, fourth, and sixth.
So if you got 7 snakes here, how many do you have at your house?
0. All animals are here.
I don't think.
The only animals I have at home are my
Okay,
children.
but.
That's all I need. Need more animals.
So I was talking to my mom about trying to sink my kitten to school, and.
Why?
Well,
Would you bring a cat?
the kitten was climbing into my jacket pocket this morning, and I was joking around with mom, like, well, it wants to go to school, it wants to learn something, and Mom's like, no, you don't want it to go. I said, why not? She said, remember, you're 5th grade and snakes. It's just the right size. So it's like, true, but they stay in their cages.
I'd be more concerned about,
The trouble I get in,
well, students who don't like cats.
or students who's allergic.
You know, I might get it.
Okay. My mom's been wondering what happened when we did all that to the soap.
Oh, yeah.
But she doesn't want to waste the money on soap, just to do that. The funny thing is the Irish race is exactly what, my stepdad.
I am trying to position this tripod the way I want it so that I can get the results I need.
Are we getting in our group today?
Maybe.
You get stupid cat. Your cat. Hey guys. Hey guys. Okay, I want to show you a video. Bit my jaw. He bit your jaw. I bit my jaw.
All right, so you guys have to do me a favor.
Oh.
Because you do this every day, I'm totally cool with it. What you need to do when you're done, is you need to come up here and
Back there.
Okay, got it. You can always hear it. Wait, is it on? Yeah, it is on right now. Alright, okay. I want to show you the fish drew. Okay. You have one job in the group, draw a fish. This was his fish. That was what you're supposed to draw. Okay. Who did that? Oh, one job. Draw the fish. Okay. What you drew? Hey guys, let's get really up close and personal. Hey, no one. Yeah, he likes them. He thinks they're fun. Go look at me. Go look. Go look. Hey. What do I look like? Ready? Can you see me? Can you see me? Okay. Hey. Get me closer. Get me closer. Go. Hey. Wow. That's cute. Hey guys, so today we have a great video idea. So, my Aunt Lucy to our cat. Go get our cat. Hey! Hot dog water. Cat! Come on. Come on. Our cat's over there. There. Yeah. Right over there. There. We'll show you what he looks like later.
Oh, yeah.
Where do I sit now? In the floor? In the floor? Same as before.
Wait, did we move seats? Oh, you said seat.
Yeah, someone said
Come on,
they take
bro.
it.
Come here.
Free.
All right, if you got some candy, it's because you had your notebook open, ready to go.
Yeah, that's like right there, like the seat. Or can I get like one of those seats?
No. We might move you in a bit though.
All right.
Let's put my food.
Bro.
What do you?
I don't watch Inside Out.
Yes, Jack. Yes, Jack. Yes, Jack.
Okay. Yeah, Negro. Oh, no.
It's John.
Mr. Taylor.
Yep.
Hot sauce.
Yeah, that's like ghost pepper.
Hey.
Yeah, try it. It's good. I took some.
It's pretty good.
How do I do not take it?
You try it and you roll.
Yeah, I tried it without no milk.
I didn't see no turkey.
I'll just cry.
I'm sure there's some.
What my son made here?
Look at me with a straight face without smiling.
I'm hungry.
What
Guys, this is not how we behave. We come in, we do our writing, and we sit quietly and wait. All right, Aiden, what's going on then?
I was talking to the teacher about one.
All right, start being on time. Leah, what did you label yourself as yesterday, introvert or extrovert? How did you label yourself yesterday? Introvert. Karen? Brooke? Ambivert? Both. So,
Do you have any tissues?
I don't, the bathroom does.
Okay, yeah, go get one.
Yep. Jesse, where are you? No. All right, so I'm gonna rearrange one of the groups and make a new group. Jesse's group of Chase, Mikhail, and Alan is now going to be just Chase, Mikhail, and Alan. And then Drew, Gage, and Jesse are gonna be together.
Just you, that.
All right, so what I need you guys to do is, first of all, let's talk about, actually, no, let's not. Go ahead and turn to the front of your composition book. We're gonna switch to that. You should be on page 2. You probably already have something there. If you do, either way, even if you don't, on page 2, what you need to write is pogil. We're gonna do a pogil today. I'll show you what that means in a minute. And then you need to write experimental variables. So if you already have something written on page 2, which you might, put a line underneath it and put pogil. And then experimental variables. That's the name of the assignment for the activity. Page 2 in the front. Wait. Yeah. Yeah. So on page 2, you probably already have something written there. Go ahead and write, variables.
Do we need to put pogil no matter what?
Pogil is a type of activity where you're in groups and you have roles within the activity, and you lead and guide each other and help each other through the information. Everybody participate. Yes, sir.
Who's the best real quick?
Yeah.
Wait, we're still.
All right. Okay, so if you would please get in your groups. Get into your groups, take your composition notebook with you. And of course, the group is Gage, Jesse, and Drew. You guys need to get it.
Gage, Jesse, and Drew. Oh, no, you're like, where's he at?
I was in.
Where is it?
Oh, yeah.
That's not fair.
No, go over front, then you get to sit there. That thing ain't $20.
He likes it.
What?
See, Jesse? Make it nice. Yeah, if you want some maybe hot water. No, there's only one hot water. I don't know where it is.
Okay, let's see, Gage, Jesse, and Drew. Yeah, Gage, Jesse, Drew, we're gonna use that table back there.
Here, dog.
Hey, where's that thing that sticks?
Do we write all of that?
Okay, now, guys, to be effective with this and to continue with activities and labs and whatnot, I need you guys' full cooperation. Okay, by this point in the day, I've already had 2 or 3 classes and they've been good or bad. And I want the experience with you to be a good one so that we can continue to do these activities. When they open this door, the air pressure changes and it pulls that door back and forth. Sometimes it's so it's important that when I'm talking, you listen, and when other people have been designated to talk, in other words, they have a talking ball, that you listen as well. All right. So right now, what you need to do is decide your roles. There's 2 roles, and the third person is just a contributor. Everybody's a contributor, so everybody has a job. But then there's 2 main roles for today. I need a leader. The leader's job is to read the questions to the group, and the group discuss it. The contributor, conductor is the other role. And the conductor's job is to make sure that everybody contributes. Everybody's talking about the questions. Now, the other role that we have is you're not allowed to talk to other groups. You only talk to your group. In fact, let's have you three move to that table because everybody, we got enough room here for everybody to have their own spot. If you want to take one of those chairs with you for today, that's fine. The last 5 minutes of class, yes. All right, now,
You just use that chair, Cat.
I'm just moving that
I'm the leader. I don't think it works.
you are correct. That, it's actually. All right. Stop. You need to be in a position where everybody can see the paper I passed out. It's 2 pages, but the pages, it's not, you get a page, I get a page, it's not, we all need to see the pages. Okay? All right. So what you've written down is a pogil, and a pogil is an activity where you work together to solve a problem, and everybody has distinct roles. The name of the pogil is experimental variations. Experimental variables. And anytime we come across bold words in this document, that scientific language that we're going to need to understand and be able to use. So at some point, you're going to be graded on your ability to use these words in scientific discussion. So you'll need to write them down and know what they mean. The first word that will come across is variable. Okay, so in your composition notebook, write down the word variable and be familiar with its meaning. Be able to use it. Be able to use it in a sentence. And I think you'll be able to see the other words that you'll need as we go through this. All right. Let me. Now I'm going to have this displayed up here, and I'll dim the lights a bit so that you can see where we are, and we'll be able to put through it together as well. Okay, so try and position the paper so that everybody can see, and I'll have it up here as a backup as well. You are correct. Your observation skills are amazing.
We were working on last week.
How do they put those things in?
Look at that. That was so complicated. Yeah. It makes you learn something.
All right. So now what I need you to do. As you're ready. All right, now what I need you to do is follow along as I read this paragraph together. You can either watch up here or look at the page that you've got in front of you. Why? When scientists set out to do an experiment, they first think about the variables that may affect the outcome of the experiment. A variable is any condition that may cause a change in the system being studied. That's a great definition. Something to be very familiar with. Jason, picking up my vibes? Why don't you write them down? Huh? What's a variable? All right. So variable is any condition that may cause a change in a system being studied. Some variables are measured quantitatively, like temperature, mass, or height. Other variables are recorded in a qualitative manner, like color, texture, or species. The most important factor is that the scientist runs a controlled experiment. A controlled experiment is when only one variable is changed to ensure that the effect of only that one variable can be measured. Okay, so we're going to be looking for the variables in this experiment and how to make it a controlled experiment as well. All right. So what are the words that you should probably have written down in your composition notebook at this point? What else? Controlled experiment. Very good. Looking down this first page, can you see any other words that might be significant? Looking down this first page, what other words are bold that might be important?
Quantitativity or something? How you say this?
I can't say it.
Okay, looking at the first page. No, you seem a little distracted.
I got them written down. Dependent variable?
No, not on the first page. Word, thank you. Photosynthesis is one. Who's the other one?
Aquatic.
Aquatic plants. Okay. Oh, look at that. They're up on the board.
I didn't already see that. I'm like, what?
Show them where it is on the paper.
No, I've seen it, like, I see it now, I see it first. I don't know, like, I wasn't paying attention to that. You said aquatic, so I just.
All right, now, we're looking at a model. So this is model number 1. And I want you to take a minute with each other and try and see if you can come up with a working definition for model. Okay, so take 1 minute trying to define model. What is a model? I should hear talking at this point. What is a model?
Why is it?
Then we got a definition, Mr. Taylor.
Okay.
Good. Hey, Mr. Populate, can you stop? All right, who wants to share their definition of model?
I said a figure representing something.
Okay, good. Anybody else?
Good.
Model is something that shows what's gonna happen, what's happening.
Okay. Anybody else?
Models like what's being tested, like what's being used.
Okay, I can see that way. All right. So what I need you to understand is that a model is a representation of a phenomenon. Okay? The model represents, okay, represents a phenomenon or an observed event. So right now, I'm throwing this foot sack in the air, and it could be a model for a baseball.
It's not.
Okay. I could say, pretend this is a baseball, and that is a model. So this represents something else, right? So that's all a model is. So right here we have a model of a process that happens, and what I want you to do with your group's help, I want you to label the components of this model. Every time you see a model, you need to label the parts of it, especially when it's this kind of model and not necessarily a chart. Okay? So label this, label the components of this model. Right directly on the paper.
Oh.
Yep. Write it right on there. What are the parts of the model? What are the components of the model?
What
What is this? What is this? Or a beaker?
So that light, it was because the plant is light.
The parts of the model. Here's your model. What are the different parts of it?
We got the white and
What else?
the water and the plant nutrients.
I don't know if I see any nutrients there.
We can't, but it's an observation, we know that.
Wait. If you don't see it, you can observe it?
Oh, no, an inference that you know that the plant's getting nutrients from the light.
No. Plants don't get nutrients from light.
Yes, it does.
No, it doesn't.
It's its food.
No, it's not.
Yeah, huh, because the plant takes the food from the sunlight.
No, it's chlorophyll, right?
Plants make the food. Sunlight is what causes it to happen. It's not what makes it. Carbon dioxide is what makes it. But you have the right idea. It's got a little bit mixed up. That's okay. That's why we're here. Okay, raise your hand if you've got the parts labeled. Oh, all right, Emma.
No.
Share with us what you think the parts are, or what your group says the parts are of this model here.
Okay, there's a jar.
Okay, hold on. Guys, hey, Emma's the only one who should be talking. She's the one with the ball.
Okay, so there's a jar,
Can we call it a beaker?
beaker.
Okay.
There's water.
Water.
Plant. And then there's a light.
Good. Plant. We got light. We got a lamp. What else do we have?
I saw the last thing, shit. I'm playing. The water. Oh my gosh, it's already up there.
It's all right. All right, we got water. How come no one's mentioned gas or oxygen?
You can't see it.
But you can in the model, you can.
Who else wants the ball?
It's not. Hey, hold on. Hey. If you see it in the model, then you see it and you can observe it. Now, obviously, we can't normally see oxygen. That's why this is a model.
Oh, that's why it's saying.
Because it can show us things that we can't really see because it represents those things we can't see.
Right.
Okay? All right. Now, something that's very important. In models like this, oftentimes there's things that are flowing or moving. You always need to show what direction they're moving. Okay? How do you do that?
Arrows.
Arrows. So put the arrows where they need to go on this model. Dale, Alan, Chase, you should be working together to show where the arrows go on this model. So Mikhail, why don't you swing around so they can see it better? Where's your movement in the model? Hey, Mikhail, talk about it before we draw it. See if they agree.
Okay, what do you think?
Emma, what do you think first? What do you think is moving in there?
The bubble.
Good, where are the bubbles going?
Upward.
That sounds good to me.
Oh, those are bubbles? Oh.
How do you know they're bubbles? You do. What's the label say?
Unless it's got big after.
Oxygen.
Yeah, what's that? Yeah, that's air, right?
Wow.
All right, who's got the ball? All right, who can volunteer to tell us where the arrows go?
Someone needs.
All right.
The arrow,
Hold on, you got the ball. Go ahead.
one arrow is coming from the lamp to the plant.
Okay, we gotta show the direction of the light. Very good. What else?
The plant, growing up.
Yeah, the plant's not really growing enough for us to put arrows on it. Plants grow pretty slow, but I can see that argument for why you'd include that, so I'm not gonna count you off. That's okay. But what else do we know for sure is gonna move in this model? Go ahead, pass it on.
Oh, don't. Okay, the bubbles,
The bubbles, what are the bubbles doing?
they're going up.
Yep.
Yeah.
So, you guys catch that? You should have arrows on those bubbles because they're gonna go up. You don't have to do it on every one, but you should have at least 2 or 3. All right, very good. Now, what I want you guys to do is, all right, one person from each group, raise your hand. All right, so that person is student number 1. Now I need another person from each group. You're now student number 2, and the last person, you're student number 3. Okay? So here we go.
We don't have another.
I know, so you have to double up. So whenever it's the third person, you guys do it together. So the leader is going to read the question. The student who was assigned is going to answer it. Okay? So student number 1 does letter A. Student number 2 does letter B. Student number 3 does letter C. Okay? But the leader reads it out loud so everybody can think about it. All right, Mark said go.
Moving so fast that we're building upstairs. I did that down there. No, it's it. Wow. What's moving so fast? There's building up here. Yeah, it's like producing. Okay.
Okay, now the whole group needs to answer number 2 and 3 as well. Who's the leader? So yeah, read number 2 and answer together, read number 3 and answer together. No.
Wow. What is it?
Number 2? No. Doesn't say that. What does it say? What are you answering? What are you trying to answer? You can answer that. Okay. So how are you going to find out how much gas?
Oh my God.
How do you know there's gas in there anyway? It doesn't tell you. No, it shows you. It shows you this is the gas pump. How do you know there's gas in it?
the intensity and duration.
I don't care what it is.
Of light residue. The last thing I have is if the soil is more acidic or basic.
Okay, so why don't you know how many there are, how much gas there is? So answer the question and be specific.
This is a heck of a lot.
Or what?
Basic.
Hey, you guys are talking about the top.
You're basic. Look at you.
Or gas.
So A, B, C, is 2 and 3.
Don't get the hardest question. How is the hardest question?
I know.
Sunlight, photosynthesis. No, there's a window, there's a light. It's not a very good sign. No, I didn't. I wrote down oxygen.
I'm so smart.
I was not.
Everybody does 2 and 3 together.
No.
Okay.
A, B, C answer, now you and 2 and 3.
Okay.
All right, we need some more time. All right, I'm giving you 1 more minute.
I need to do. Oh,
No, I didn't say it.
Can I go to the bathroom? Like, I just finished
Great.
Okay, so I'm gonna go.
Now I'm done. Okay, let's go through this. Everybody's attention, please. 3, 2, 1. Still waiting. All right, the process is, what's the process, excuse me, what process is occurring in the plant cells to produce the gas and the bubbles that appear?
Photosynthesis.
Very good. What gas is the plant producing?
Oxygen.
Oxygen. What's the source of energy for the plant?
Light.
Very good. Now, how are we going to know how much oxygen there is?
Count the bubbles.
Count the bubbles. Good. All right, and then what are some of the factors in the environment that might affect the rate of gas production? Yeah.
The light, the amount of water, and the size of the plant.
Okay. Yeah, those are all possible. Yes.
The surrounding light, the area soil acidity or how basic it is.
Okay. Yeah, those can be factors. Right. All right, good. So let's look at the next model on page 2. Okay, so page 2's got our next model. What do we do the first time we look at a model?
You examine it.
You label the parts, you label the components. Now, on this one, you're only gonna label the letter D. Letter D is the bottom right. Okay, so go ahead and label them A, B, C, and D, and then work together to label all the parts of D. Okay, so A, B, C, D, label all the parts of D. Ready, Mark, say go. You label the parts there, Nick?
What is deflecting?
What?
Look on. Oh, I got it. He said spelling doesn't count. That's a different word. No, it's not. I'm the leader, I'm the
Hey, no acquitted people, please. I know she's really expensive. All right, hold on, guys. You should have labeled all these parts now. There are 5 parts that you need. Okay, you need the light, you need the plant, gas, beaker, and screen, or water tube. So you need the screen as well. That's going to be a screen. The screen's going to be important. Okay, so identify, for number 4, identify what are the parts of these trials that are the same? What do you notice that's the same in each trial? Yes.
They're all underwater.
Okay, so water's a factor. What else?
They all got light.
They all have light.
They all got gas.
They all have a plant. Good. So you gotta have water, plant, and light. All right, water, plant, light. Now, go ahead and answer together. Answer number 5 and 6. We just did.
No.
Just pay attention. Okay.
Well, I was, but I didn't know you were talking about that.
All right.
This is 2. Okay. What do you think? Oh, okay.
Wait, do you agree?
Yeah.
Why? Why do you agree?
No.
All right, your last one. Make her help you. Hey.
You know the things.
Yeah, it's much less. Yeah, it's much less. Yeah.
really run. Much less mesh.
No, much less.
Hey, just share all. We have to plug that in today. Just share the Google Doc. Yes, I mean, okay. All right, so I'm just gonna send our doc. Okay.
You guys are running out of restroom visits pretty quick here. Oh, wait. Okay, good, let's go on. As you guys noticed, the condition being changed is the screen. What do you think the screen's going to affect?
How much lighting?
How much lighting? Very good. Very good. All right. All right, let's go on to model number 3 on page 3. All right, you guys should look out the window like you've never seen a bar before. Oh, good job. Thanks for sharing with us. All right, now look at the model on page 3, the third model. I want you to talk for 30 seconds. What are the patterns you notice in that model? All right, now go ahead and fill it. Go ahead and fill it in. Go ahead and fill in the rest of that chart based on model 2. And if Alan, I want you to do it. Help them out. Fill in parts based on model 2.
Based on model 2.
Fill in the parts based on model 2.
Oh, it's going down by 2.
Decreasing by a quarter.
2.
A quarter is each.
No. I think I'm right.
You are right.
All right, now go ahead and work and answer number 8. By the way, how many leaves are on each clipping?
9.
8.
What?
8.
1, 2, 3, 4, 5, 6, 7, 8.
There's 9.
You know what? I do see 9.
Just 9.
I see 9 too. Go ahead and put 9. There's 5 on one side, 4 on the other.
What?
So where I'm from, that equals 9.
3.
Now that was what changed. The bubbles.
What variety in model?
Yeah. Does anybody ever know actually how many skin cells are on the body?
Yeah, there's too many to count.
You're educated guess.
Billions.
How many does it take?
There's a lot more than millions.
Wow, they're smart.
They believe there's between 4 and 10 trillion cells in the body.
That's scary.
What?
I guess if you're scared,
How many
nobody is. Kind of. Your whole body can generate those.
Never the girl.
It's more than just.
Aren't they like, aren't they like parts that go on your body that you can't see?
Are they who?
Isn't that like little itty bitty parts that live on your body you can't see?
Yeah, that's on the old place. Hey, you guys got an answer? Let's go, come on. Who's the conductor controller?
That would be no.
Hayden, look at us. Yeah.
So if he's conductor, what are you?
No, I'm not thinking about it.
I'm saying. You both have responsibilities. I see you flicking around paper over here.
No,
And he's reading the question, you're bouncing your head.
I have responsibility.
No, conductor, make sure everybody's serious.
What? You said like, you said the interpreter like, there was only two like someone like.
No, I said there's, everybody has a contributing role. There's two lead roles, leader and conductor.
You don't do anything.
All right.
No. You tell them.
All right, what do you guys got? Okay, what are what variable is purposely changed in the experiment?
The percentage of light.
Good. How is that changed? No. Hey, hold on.
Oh.
Okay, Haley should be the only one talking. Go ahead. How is the amount of light changed? Haley, look at me. How is the amount of light changed?
Because. Oh, what, the number?
No, how do they change how much light's coming through?
Oh, the screen.
Right, there you go. Good. All right. And then what variables remain the same throughout the trial? Go ahead, Katie Taylor.
The length of clippings and the number of leaves.
Good. Length of clippings, number of leaves, water. Oh yeah, I'm sorry. I got out before. All right, very good. Put the staple of papers and put them on the counter over there and put them right there. There you go. There you go.
Yeah. Oh, you're just going.
Hayden, that dude looks like there's a wall.
Okay, ball up. Oh, you're gonna be a writer. Oh, great.
I'm gonna be Here's your ball.
What did I do to my phone? Why is
I'm sorry to get my new back.
personnel, let them know how they're doing people. He's gonna get slammed.
Bye, Mr. Taylor.
All right, man. Good luck.
Alicia Taylor to the main office. Alicia Taylor to the main office.
Mason, how do you sell so many magazines?
Daddy.
Hey, Mr. Taylor.
Hey,
Hey, get some water.
why you asking, bro?
Thirsty.
Go get one. You want to ask?
Marion. Meet Garcia.
Hey,
No, I can't sit in a regular chair. Why would I do that? You want to put the This one's
Probably. Yeah.
Well, giving people got their stuff out, working already.
And define a sign.
Oh, I got my map.
Hey, Mr. Taylor, you didn't look, but it was on the table.
No, well,
Yes, it was. That's
No, well,
that's the very.
I saw only me.
Wait, David, can I get one?
I give to those who have their books out and open.
I don't have that book, so it's.
I'm a math one open.
Was it open?
Maybe I gave one to Mary by accident then.
It's there in the ones. They just gave it to me.
You guys should be ready when the bell rings. Some of you are still sitting there after the bell rings. That is, that's just garbage. Yeah, throw it away.
Well, how was your day, dude?
We'll see how you guys do today. I'm outside.
How's it been so far?
It's been survivable.
What happened?
It's the 8-year-old baby.
Brady didn't get to see it.
Yeah, let's see it again so Brady can like.
No, watch it.
Look up Adam Taylor on YouTube.
Cody, you see the attitude needs to work.
What attitude?
The attitude that you haven't even started yet, you're asking all these questions, you're mad you didn't get the answer you want. That attitude.
I'm mad.
I didn't say you were mad. You had an attitude. Really? That's the guy that hasn't read the word yet?
That wasn't me.
Oh.
It wasn't even me.
You better get on his head.
I didn't even.
Get on his head. This is my favorite class.
All right, who wasn't here yesterday? That's fine, they can turn the knob and come in.
Figured it out.
Yeah, didn't need your comments, guys, not necessary. Thank you. So everybody was here yesterday?
I was it.
Oh, yeah. Saba.
Are we gonna get our cheap tanks today?
Okay, all right, Rosaba, I'm gonna have to work with, Queen, Brianna, and Alexis.
I got her hair pulled out.
Wait for here.
You are correct. And Brady, you're gonna work with Xavier and Harsh. Zach?
I actually watched that video.
All right, turn to the front of your composition notebooks. I should. So it should be on the second page. The last place you wrote, and I want you to write pogil underneath the last name. Put a line all the way across, and underneath it put pogil.
It's a weird name.
It all had that.
Then underneath that, write experimental variables. That's the name of the assignment. All right, go ahead and get your groups from yesterday.
Should we bring our stuff?
If you want to.
I'm leaving mine. Well, ours doesn't have any shirts.
Camera off, hot.
What are you doing?
Get your own stuff.
Are you back here too? Is she in our group? Hey, Mr. Taylor. Give her a
No, but you guys are in the wrong place, that's why.
Oh.
That wasn't where you sat yesterday.
There's no, chairs.
They can have some. Dingleberries?
So you can have dingleberries.
Yeah.
Dingleberries.
I'll sit in the middle.
Sit on the outside over here. Where is it?
No.
chair is falling apart. We can adopt Brady.
Brady was here yesterday.
Brady's our first option.
Oh.
Welcome to science.
You guys are working on this page together. We'll get closer, working on this page together. All these together. Yeah, I signed with you guys. Page together. You gonna work on this page together? All right, so what you're gonna do is you guys going to read along as I read out loud. Read along as I read out loud. When scientists set out to do an experiment, they first think about the variables that may affect the outcome of the experiment. A variable is any condition that may cause a change in the system being studied. Some variables are measured quantitatively, like temperature and mass. Other variables are recorded qualitatively in a qualitative manner, like color, texture, or species. The most important factor is that the scientist runs a controlled experiment. In a controlled experiment, only one variable is changed to ensure that the effect of only that one variable can be measured. Okay, so on your composition notebook, you need to define variable and you need to define controlled experiment. So in your composition notebook, define variable and controlled experiment. All right, I want to give you guys 1 minute to explain what a model is. You can see we've got model 1, photosynthesis and aquatic plants. I want you to come up together with a definition or an explanation of what a model is. You don't have to write it down, just think of it together. Yeah. Talk about it. What is a model?
A model is a graphic representation
All right, who can share what a model is? Marion's the only one with the ball, and Marion should be the only one talking.
A model is a graphic representation of what is being shown.
Okay, that can be true. Good. Who else?
Let me throw it at me.
We don't know.
Anybody?
What's the question?
I mean, I'll tell you the guess.
What's the question?
Hey, man, you get the back wall.
Hey, go ahead and answer it while you're getting it.
Maybe it's like a visual, like showing someone like in a picture or something like that, maybe?
Showing what?
Like a graph or something like that. That.
Okay, graphs can be a model.
A model is something that represents a phenomenon. I can't remember.
Somebody can read the board. Very good.
No, but that came out of my brain. And that's
So-
what I answered.
Sure did. That's why you were pointing at it when you read it. Yeah, so a model is a representation of a phenomenon or an observed event. So if you were to say that this is a baseball, and I'm going to throw it out with my right hand, catch it with my left, that is a model. This represents a baseball in a natural phenomenon or observable event. Okay? Anything, well, lots of things can represent other things. If they represent other things, it's considered a model. Now, you have model 1 on page 1. As they group together, write on the paper and label the different parts of the model. As they group together, write the different parts of the model on the model.
Like the different parts of the model on the model.
Okay, as a group, model.
Label the model.
So that would be.
All right, who's got a label? All right, what do you have on your label?
The leaves and plants in it, like the.
Okay, so we could say plant, or we could actually label the stem and the leaves if we wanted to. Good, what else? The light?
And
You could say lamp.
And is that, it's like the oxygen in there, is that what it is, or is it like water?
Hey, guys, Mackenzie should be the only one talking.
Is the,
Aggie and Lindsay, what are you guys doing? Huh?
We're writing lamp.
You're labeling? All right. The way you were exchanging was like you're playing tic-tac-toe or something.
No, she's
No,
writing
drawing my
here.
All right, that's good.
there's a container, and is that like?
Can we call it a beaker?
I thought it was maybe liquid.
I thought it was liquid, but I read it and it's oxygen.
Liquid.
Well, the little tiny circles are oxygen,
Oh,
okay? So this is probably water, right?
yeah, water.
Because that's what aquatic means, right? Water?
Uh-huh.
Okay, so photosynthesis and aquatic plant used to go on your list too, in your composition notebook. Okay, so we're learning the language of science. These are words you need to be able to use on future quizzes.
Wait, what did you want us to write in our book?
Photosynthesis.
Just anywhere?
No, it's the next word underneath, controlled experiment. Okay, so we got beaker, we got water, we got light, lamp. Now, is there anything moving in this model?
No.
The light.
There are two things that should be moving. One of them is the light. We always need to show where they're moving to. How would we show that?
Like the arrows.
Yeah, so let's put some arrows here to show that stuff's moving. Okay. What else is moving?
The plant looks like it's moving.
No,
Like oxygen is moving.
the oxygen's moving. Where's the oxygen going?
Oh.
Yep. So show the oxygen going up, at least 2 or 3 of them. Okay, so always label the components, always show where things are moving. All right,
Are we supposed to point the arrow for oxygen upward?
that's where it goes, yeah. It is air, so it goes up and when it's in water.
He was like this. I thought he's like raising his hand. No, he's laying like this. I swear he was.
So you're throwing stuff at people.
He had his hand up, so I was gonna throw it to him.
But he wasn't looking.
You're doing this.
Yeah, but he wasn't looking, so it doesn't make sense.
He could have caught it backwards though.
Sure. Because that's possible when you don't look and know what's wrong.
We're not pencil.
What was the definition of photosynthesis?
You don't need to find it, you know what it is.
So just put it on that way.
Yeah. All right, now, what you're gonna do is you're gonna take turns reading the questions and answering them together. So rotate who reads the question, who answers it. I want you to do 1 through 3. Okay? Rotate who reads it and work together to answer it.
The process in the plant cells to gather and focus that here, stop that.
Yeah, I know what you're about to say.
Like, go, I'm not done. Why is
You have to write in the book? Okay. You have to write it in the book.
No, on paper.
What are gases the plant producing?
So for number 2, we should draw a picture of like, we'll draw a picture of right. Okay, no.
Read the question.
I didn't.
And what's the answer? Does she know the answer?
No, she's not.
You guys need to look at the question deeper. What's it asking?
Let's look deeper.
What's it asking?
No. I don't understand it.
What's it asking?
Suggest a method for measuring ratio methods of production in
Method for what?
Yeah.
I want Lisa to say it too.
Yeah.
So what do you need to measure? Right. What are you gonna do with this method? Read the rest of the question.
We're gonna say what you should, how you should measure it.
Okay, good.
We're writing numbers.
All right, so what numbers would you write about the option?
Oh, Dave.
Why do you always resort to the side? Read the question.
What's your brother?
Alright.
Michael.
I have a bad problem like this.
What's your group create a list of environmental factors that may affect the rate of gas production in the aquatic plant? These factors could be considered.
I don't know, I can't, you don't have to read it.
Water.
Okay.
Water. What? Being very
We only do 1, 2, 3, right?
For the moment, until now, yes.
Okay.
All right, so let's go through this real quick. Letter A, what process is occurring? Everybody.
Photosynthesis.
Good. Letter B, what's the plant producing?
Oxygen.
Good job. Letter C,
Heat energy from the lamp.
light. Or energy from the lamp is fine too. Now, depending on the environment the plant is in, more or less gas may be produced. Suggest a method for measuring the rate of gas production from the aquatic plant.
Count them.
Count what?
The little oxygen bubbles in the.
Yeah, count the bubbles. Very good. All right, and what, would your group create a list of environmental factors that may affect the rate of gas production in the aquatic plant?
We put reducing the amount of oxygen, but I don't know if that's right.
Well, it can't be right. What?
Okay, then.
Because that's what you're counting. So if that's what you're counting, you gotta do other things to change what there is to count.
Add more oxygen bubbles. Oh, here.
The plant making them. What are you gonna do to change the amount of oxygen you produce?
Lower the brightness on the light.
Okay, change the brightness on the light. What else?
Lower the plant.
Well, the plant has to be there. You can't measure oxygen.
Ooh,
How can you measure oxygen produced by the plant? The plant's not there.
exactly my point. No oxygen, no plant. No say no oxygen.
All right, Mackenzie?
Can you take the water out, like take less water out?
Oh,
Okay, you can change the water amount.
put a
That's
lid
possible.
on the beaker.
Okay, maybe that'll help. Good. All right, let's move on to Model 2. Turn the page.
What did you eat for lunch?
You ripping some gas over there, bro?
I'm so upset.
All right.
I'm pretty bad, yeah.
Anyway, all right, so looking up at the screen or at your paper, you should be on the second page.
What's on the screen?
Nothing. Why do you guys tell me?
So I didn't know.
All right. All right, so we have 4 trials here. You need to label them A, B, C, and D.
Wait, how do you do it again?
A, B, C.
A,
Okay.
B, C, D.
E, G, H, E, A, D.
All right, now with your group, I want you to label all the parts of letter D. Hey,
Wait, say it again. Label all parts.
label all the parts of letter D.
Where at?
On letter D.
No, on the paper.
Okay, Mackenzie, you can't do it all. You gotta make them do some too.
Yeah, man, you do something.
What had been?
Yeah, they've been contributing. They
Okay.
can say something. I
Okay.
did, right?
Okay. How's that clear all in while you're doing all the work? I believe you. I made
How's the plant standing up and drinking off? Air.
Mr. Taylor, what does that say? What does that say?
I would call it a screen.
So we're just doing D, right?
Yep. All right, so in your labels here, yeah,
Oh, I want to answer.
you want to label it? I think I'm gonna let the girls in the back label it. All right, so what do we got here? Got a light,
So,
a lamp,
is there a wall? It kind of looks like.
and lights. What would this be? A screen,
Wait, plant, water.
plant,
Water.
water,
Speaker.
and oxygen.
Speaker. Apparently.
Okay, good. Go ahead and answer 4, 5, and 6.
All right.
Take turns reading it and work together to answer it. Hey, again, I see her doing work and you guys just sitting there.
What's the brief one? Snake.
Heavy liquidness on the screen.
You're supposed to take turns reading the question and working together to answer. Is it water or oxygen?
It's water, and then there is let go oxygen.
Just like bubble, it'd be bubble.
It is bubble. You do not have
What is that? If the holes are smaller, what's happening? Yeah.
I think I should have took biology. Wait, is this a credit? Is this class a credit? Does it you have to have a physical science credit?
No, you set up 3 sciences.
Oh, okay. So if I take, I don't have to do science.
Ow.
Bless you.
You might slow down a little bit.
I'm ready.
Not my goal. Or that hole, not my goal. I can already go with this.
If you can say maybe go down.
Slow down, gas. You'll see things, gas, oxygen.
Make them.
Dude, Cody, I'm trying to find your pencil.
I think it's all forever.
I think I can find it. Oh, wait.
All right, so we noticed that in number 4, we noticed that several items in each of the trials are the same. We see the light, we see the water, and the plant, right? And so What they changed was the screen and the amount of light that gets through. Right, for number 5. And then on number 6, how does the light that gets through affect the plant?
Are you asking me?
Sure.
Okay, so the less light there was, the less oxygen there was.
Okay, where's your evidence of that?
Okay, in model A, there's no screen and the light was belong to the plant, and there's 1, 2, 3, 4, 5, 6, 7, there's 8 little oxygen bubbles. And then on model B, there's like a light screen, and there's only 1, 2, 3, 4, 5, 6 oxygen bubbles. And
Okay.
in each model, the screen gets heavier and the bubbles get
Very good. Notice how she gave me numbers and details. Those numbers are important because this is quantitative information. Very good. All right, let's turn over to page 3. Now, you're going to need the information on Model 2 to answer parts of Model 3. But for 30 seconds, talk to each other about the patterns you see on Model 3. What are the patterns you see in Model 3? All right, now go ahead and fill in the chart for Model 3. You need the information from Model 2 to answer it. Yeah.
I'm done.
All right, when you're done filling in the chart, go ahead and answer number 8.
What did we do? I still have my food. Really? I don't think
Susie, stop doing all the work. Make them do something with your life.
Just doing it myself so it'll be right.
They don't want to charge. Why is going about
Here's
it?
the other one then.
Because she cares about your future. She wants you to progress. Graduate.
Sorry.
Yeah, you just proved
Here's
it.
that one.
You just proved it.
What?
All right.
You're looking at me. Can't do it, man. How you gotta do it? All right. Now, do you think that's a percentage?
Whoa, you're snaky too. Ow. Oh.
All right. Letter A. What variable was purposely changed? What variable was purposely changed? Xavier? Yeah, the screen was changed to let the percentage of light change. Good. What variable changed as a result of changing the variable listed in part A? Yes, that.
Number of oxygen bubbles.
The number of oxygen bubbles. Very good. So there was less oxygen when there was less light. What variable in Model 3 data table remained constant among all the trials? What variables stayed the same, Mackenzie?
The length of the clipping, the number of leaves, and the lamp power.
Good. Okay, so there were a few things that stayed the same. And those things that stay the same are very important. Okay, so let's look at this next section here. Okay, looking at this next section, it says, when designing an experiment, this is important because you're going to be designing an experiment in a minute. Okay, so listen carefully and read along. When designing an experiment, you need to consider 3 types of variables. The independent variable is changed by the experimenter in the design of the experiment. This variable is sometimes called the manipulated variable. The dependent variable is what changes as a result of the change in the independent variable. This variable is sometimes called the responding variable. In some cases, more than one dependent variable is considered. The third category is controlled variables. These variables are that you think may change the outcome of the experiment, but since they are not being studied, they need to be kept constant in each trial. All right. So in your notebook, in your composition notebook, you need to add independent variable, dependent variable, and controlled variables. Yep. Right there.
Sure, the definition, okay?
As long as it still makes sense, that's fine.
Makes sense to me or to you?
Okay, you should be writing these right now in your composition notebook. Yeah, you also need to put their definitions. Also put the definitions. Are you kidding me?
Wait, I'm trying
Good.
to pick the other one.
Where's yours?
That's mine.
I got a whole pile of them over here, guys. Come on. This is ridiculous. That's been the whole period. You haven't used your
This is
own.
why they don't.
I did have mine at the beginning of the period, but it fell down and the unforgiving.
So, what did you learn from that experience?
To not let Mason have my pencil.
You said put it in there, let's try to break it.
Come on, guys. You need those defined words over there.
We put our notes in the front, right?
Yes.
This to go in front, right?
Yes.
Get your, where's your snake? Snake's being weird.
It's interesting, not weird.
I think in science is weird.
I think weird is fine. As long as it's not gross or new.
It is both.
No.
So if you guys want to what?
No, I'm supposed to leave. Sorry, Cody.
Where you give it to me?
I don't know where it's at.
That's Tracy.
Water goes to the boat.
Again, you get over.
Oh, this.
Well, it's not really people who use what? Are they? No, you're just like, you don't go like have to say.
I wonder if the record
I didn't learn them, but I heard it. Yeah, like, you can't get
All right, we will finish this next time. So make sure both your names are on it, and go staple it and set it on the table over here. Please put up your chairs on top of the desks. You're fine, just make sure I'm looking.
If you actually did. Where we turn this in, right?
Say what?
I like to go to the hills and don't die. Where's that other page? We didn't write our name. Where's the page? Where's this thing? Over there.
Hey, Justin, put up the chairs, man.
You want me to put up this? Not falling.
Yes. Yeah, this is another you guys can go.
Huh? No, it's
Ow!
Bye-bye. 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 Bye-bye now. Bye-bye.
With it.